Hello everybody, welcome back to the channel. Today we are going on fascinating mathematical journey. We'll explore one of the most beautiful and surprising connection in all of mathematics. How a simple sequence of integer, the Fibonacci numbers, connect to the most famous constant in geometry, pi. Yes, if I ask you what pi is, you will probably think of circles, circumference, or angles. But what if I told you that by simply adding the reciprocal of all Fibonacci numbers, you can build angles that sum to exactly pi over 4, that is 45 degrees. Today, we decode the secrets. If we add the reciprocal of Fibonacci constant 1 over 1 plus 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 5 and so on equals to 3.359885. That called psi. So psi equals to sum of 1 over fkk from 1 to infinity. Daniel Danbury in 1989 proved that psi is irrational. So psi cannot be defined as integer, as a rational number. So also we have another identity, arctangent identity. Sum of arctangent are 1 over f 2k plus 1, k from 1 to infinity equals to pi over 4. We can have the expanded form of the identity. Arctangent 1 over 2 plus r would tangent 1 over 5 plus arctangent 1 over 13 plus so on equals to 45 degrees. Sum of infinite angles exactly pi over 4. Here we can see some of these different angles that start from value and then summation of all of them will be equal to pi over 4. Single angle. Each triangle has a base f 2k plus 1 and height of 1. Angle is arctangent 1 over f 2k plus 1. Sides of these triangles stack perfectly and final result exactly 45 degrees. Infinite sum of angles equals to perfect 45 degrees. Coincide that the number 2 plus geometry equals to pi. So, while the Fibonacci sequence has a Planck sequence called locus sequence and locus numbers. Locus sequence definition has some differences with Fibonacci sequences in initial values. In locus sequence, the L1 is equal to 2, L2 is equal to 1, and Ln equals to Ln minus 1 plus Ln minus 2. In yellow, for different n, we have the number of Fibonacci number and locus number. For n1, 2, 3, 5, 4, 5, 6, the Fibonacci number is 1, 1, 2, 3, 5, 8, and locus number is 2, 1, 3, 4, 7, 11. The key identities f2n equals to fn multiply ln. For example, f6 equal to f3 multiply l equals to 2 multiply 3 equals to 6. So, yes, but generate some scroll. The first spiral related to the Fibonacci number, and second one is the related to locus sequence, locus number. Also, if we add summation of n equals from 1 to infinity minus 1 to the n plus 1, or that fn multiply fn plus 1 equals to 1 over psi. So in the expand form, we have 1 over 1 multiply 1 minus 1 over 1 multiply 2 plus 1 over 2 plus 2 multiply 3 minus 1 over 3 multiply 5, and so on. Equals to 1 over psi approximately equals to 0.618. The goal in this appear naturally in this service. So also we have here spiral curve. And the big picture that the Fibonacci is bridge between worlds of the geometry analysis and number theory. One sequence is the Fibonacci sequences connect the geometry analysis and number theory. Yet in the left side, we have the pi and arctangent identity, and then the ratio is converse to the side. To the side. The ratio is converse to the phi, and the reciprocal series converge to the side. So in the center, we can see the Fibonacci numbers that connects the geometry analysis and number theory. So in this presentation, we discovered the size irrational Lipper-Daniel loops pi over 4 emerged from arctan reciprocals and phi appear from alternating series. Locus number provide complementary identities. The big idea is that the simple integer sequences bridge geometry analysis and number theory. Actually, we can't tell that mathematics in networks are a surprising connection. Fibonacci is where they meet. You can see some references related to this presentation and key identity there. Arctangent identity, sum of arctangent 1 over f2k plus 1k from 1 to infinity is equal to pi over 4. And sum of minus 1 to the n plus 1 over f and multiply fn plus 1. And from 1 to infinity is equal to 1 over phi, and f to n equals to f and multiply ln. Thanks for watching and see you in next video.